2 gram of carbon divided by 12 gram per mole of carbon. Then for hydrogen, we have 0.34 gram divided by 1 gram per mole of air. Looking at the elements C for carbon, H for hydrogen, and O for oxygen, the relative mass of carbon is 2 gram, for hydrogen is 0.34 gram, and for oxygen is 2.67 gram. The molar mass is for carbon is 12.12 gram per mole. For hydrogen is 1 gram per mole, while for oxygen is 1 gram per mole. Then the relative mass divided by the molar mass, we have that 2 gram of carbon divided by 12 gram per mole of carbon. Then for hydrogen, we have 0.34 gram divided by 1 gram per mole of hydrogen. Then for oxygen, we have 2.67 gram all over 16 gram per mole of oxygen. The molar ratio will now get 0.17 for carbon, 0.34 for hydrogen, and 0.17 for oxygen. The molar ratio over the smallest molar ratio, we have that since the smallest molar ratio is 0.17, for carbon we have 0.17 of carbon divided by 0.47 of the smallest molar ratio, which is equals to 1. And for hydrogen, we have 0.34 over the smallest molar ratio, which is 0.17. And for oxygen, we still have 0.17 as the molar ratio divided by the smallest mole ratio, which is 0.17. Molar ratio will now have a ratio of 1:2:1. Therefore, the empirical formula is CH2O. Relative molecular mass is equal to empirical formula, where A is the multiple factor. Now, relative molecular formula is equal to CH2O all multiplied by N. But N is equal to, if you multiply, you have N equal to relative molecular formula over the empirical formula. The element mass EM is now equals to 12 plus 2 times 1 plus 16 from the empirical formula, which will give us 12 plus 2 plus 16, which will give us that the relative molecular formula, if you divide this formula, it will now give us 2. If you divide it by 60, since 60 is what is given from the question as the formula, as the compound relative molecular mass, if you divide 60 by 30, it will give us 2. So the relative molecular formula is now equals to CH2O times all times by 2. Therefore, the C will now get C to H4O2, as the case may be. Example 3. A mineral contains 14.7% calcium and 67.7% tungsten. The remainder is oxygen. Find the empirical formula, where Ca is equals to 40, W is equals to 184, and the O is equal to 16. Solution. The percentage of oxygen will now give us 100 minus the composition of calcium plus the composition of W, which is 14.7 plus 67.7, will now give us a percentage composition of oxygen as 17.6. Therefore, the percentage composition by mass is for calcium is 14.7, for W is 67.7, and for oxygen is 17.6. To get the ratio by dividing the percentage composition of mass by the relative atomic formula. We have 14.7 divided by 40 for calcium, which will give us 0.37, and for the W we have 67.7 divided by the relative molecular mass of W, which is 184, which will give us 0.37 also. Then for oxygen we have 17.6 percentage composition of by mass, or divided by the relative molecular mass, which is 16, which give us 1.1. Now the smallest formula there, the smallest answer there is 0.39. Then divide by the smallest number or answer, which is now 0.37 divided by 0.37, which will give us 1 for calcium. 0.37 plus over the 0.37, which give us 1 for W, and 1.11 over 0.37, which will give us 3 for oxygen. Therefore, the empirical formula for the compound, we now have CaWO3. Example 4. A gaseous hydrocarbon contains 80% carbon and 20% hydrogen. 1 dm cube of the carbon at STP weighs 1.35 gram. Find its molecular formula, while 1 mole of gas at SCP occupies 22.4 dm cube. Solution. We have carbon and hydrogen. The percentage composition by mass of carbon is 80, and the percentage composition by mass of hydrogen is 20. Ratio of the atoms by dividing the percentage composition by the relative molecular mass, we have 80 percentage composition of carbon divided by relative molecular mass of carbon, which is 12, which will give us 6.7. And the hydrogen having 20% composition by mass divided by 1 relative molecular mass of hydrogen, which will give us 20. By dividing by the smallest and correcting to the nearest whole number, since the smallest answer there is 6.7, we have that 6.7 divided by 6.7, which will give us 1 for carbon, and 20 divided by 6.7, which will give us 3 for hydrogen. Therefore, the empirical formula for the compound is equal to CH3.